Good evening, First Robotics community. My name is Sean Lim, and I am the Director of District Implementation for First Robotics Canada. And thanks for joining us this evening for yet another episode of Ask the Experts. And tonight we've got a really great panel from two experienced teams who've had somewhat of a meteoric rise in the FRC community over the last few years. And we're really happy to be able to have them on board to share their experiences in building those programs and kind of how they look at the build season at this stage now that we're about halfway through. And so the primary purpose of today's webinar is actually a bit of a strategic review. Now, halfway through build season, your robots are starting to take shape, and sometimes, they start performing maybe not quite as well as you'd hoped, or maybe, hopefully, a little better than you'd hoped, and that may change how you feel the game is going to be played. On top of that, as you're nearing completion of your robots and the end of your 6-week build period, you're going to need to start thinking about practicing with your robot, how you're going to maximize that robot so that you're getting the most out of it on the field. And as you talk to these more experienced teams, they'll tell you just how important practice is towards producing, a good product on the field. You can have the best robot out there, but if you haven't put in the time to learn to drive it around, you're not necessarily doing it justice. Last but not least, we're also going to talk about the official question and answer system, where there have been a good number of very important questions and answers given that you all need to be aware of, and we'll do a quick review of the most important ones. And after reviewing those, that'll give us some insight maybe to what penalties are going to be commonly called, or hopefully not commonly, but most likely called during this year's game, and how to look for them and hopefully avoid them. And so to introduce you to our panel this evening, we have Matt Alderson, the lead mentor for FRC Team 4039, Makeshift Robotics out of Hamilton, Ontario. And despite being, a 4,000 numbered team, they are 3-time regional winners. And so Matt, thanks very much for coming on board with us. And Matt, would you mind just telling us a little bit about yourself?
Sure. Thanks, Sean, for inviting me to come on. I'm a lead mentor of Makeshift Robotics. I've been with the team since we started. This will be our 6th season. On the engineering side, when I'm not doing FIRST, my day job is I'm an engineering manager at SimCore Automation, an industrial automation company in Grimsby.
Awesome. Well, thanks for coming on board with us, Matt. Great to have you. And also joining us this evening is Maurice Veldhuis. He is the lead mentor for FRC Team 4678, and they are the Cybercabs out of Breslau, Ontario. And they had a very successful season last year, winning the Newton division at the World Championships and making their very first Einstein appearance at the same time. So Maurice, thanks very much for joining us. Maurice, would you mind telling the audience a little bit about yourself?
Sure. I am the lead mentor of the Woodland Cybercabs. I have been with the team since we started 4 years ago. This is our 5th season. When I'm not busy with robotics, which seems to be all the time now, but I do have another job where I'm a professional engineer, and I basically have my own company where I do mostly electronic design of ventilation controls, mostly in agriculture, like the kind of controls you'd find in barns, running fans and inlets and that kind of thing.
Awesome. Well, thanks very much for your time as well, Maurice. Pleasure having you on the panel. And without further ado, I'd like to get right into the nitty-gritty. And so we have some of our most accomplished teams in the area. I'm just kind of dying to know how your build seasons have been going so far. So I'm going to fire this one over to you, Matt. How has it been going? Have you come across any challenges with the build up until this point, or has it been pretty smooth sailing?
For us at Makeshift, we're pretty much on schedule. We try to track ourselves throughout the 6 weeks and make sure we're not getting behind. We were driving for the first time on Saturday at the Hamilton practice field, so that's a good sign. And in terms of how things are going, I think we're finding, like other years, that the tasks that originally looked simple and in the game animation straightforward, once you start getting into the details and once you start trying to figure out how the robot is going to do that rather than a human, then things get a lot tougher. So we're finding that gearing is harder than we originally thought, fuel is harder than we originally thought, and climbing is probably about what we thought, given the information that's out on the internet right now. So, so far so good. Our students are just getting back now. They'll get back tomorrow is the last day of their exams, so we lost the 5 days as is normal through build season, but we're eager to get them back and get them to put the final touches on the robot.
Very nice, Matt. And if you don't mind me, I'd like to delve into just a little bit of detail on some of the things that you pointed out there. I know gears is something that we've talked about quite a bit on the webinars, and for our lower resource teams who might be choosing just to focus on that, you'd mentioned that, you know, it's a lot of the little details with scoring gears, which turn out to be a lot more difficult than what the game animation might make you believe. From your experience, specifically with the gears, what has been maybe the more challenging aspects or the things that, you know, you would feel other teams might be overlooking?
Yeah, I think trying to test in as real world an environment as you can get, so that comes down to getting the proper spring, and we've had some help from a team down the road. 2056 had some springs made up. They were nice enough to give us a few, and we've been practicing with something that is more or less realistic, although I think there's still a bit of a wild card out there in terms of the stiffness of the spring, and that has a huge impact on the capability of a mechanism to place it properly and for the human player to hoist it. So a caution maybe for teams that don't have a realistic spring, that have been doing their testing with a stiff rod or something that isn't representative. Try to get to a place or try to get a realistic spring and really try it, because it might impact your mechanism in terms of where you place the gear, how deeply it has to be set onto the spring, and also the human player. There's going to be some gears, I predict, that are lost, many gears that are lost because the pilot doesn't handle the gear properly in terms of lifting it free of the robot or lifting it up to the airship. So as close to real-world conditions as you can get includes the spring, as close to the real one as you can get, and also the environment that you're going to be in. So from a line of sight point of view and lining up for that gear that may or may not be oriented, clocked, if you will, at the right angle for your spring to pick it up. As soon as you can get to a field and get something really realistic running, do it, because we found that both those things, the spring stiffness and the line of sight and need to line up accurately, at least for our initial mechanism, was a big learning for us, and we had to go back a couple steps before we could move forward.
I think that's really good insight, Matt. I think that's something that a few other guests on our webinar have mentioned, and so, you know, when you start hearing things like this come from multiple guests, it just goes to show how much you're going to need to prioritize it. That spring and its springiness does make a big deal, and if you hang your gear right on the end of the spring, you may not expect that to stay on there even as your robot's driving away, or to stay on there as your pilot's lifting it up. So definitely good advice on that one. Maurice, I'm going to swing kind of the same question over to you, you know, both in general and maybe we'll delve into some specifics, but you know, how's your build been going so far? Have you guys run into any major challenges up until this point?
Our build is going quite well. We thought we were kind of ahead of schedule earlier on, but again, the exam week has slowed us down a little bit. This past Saturday, we just got our drive base running, tethered to the computer, but it does move, and now we've got to attach all of the subsystems that we're planning. I agree with what Matt had to say about that spring. We had the good fortune of ordering one from Essentra, which is a Canadian supplier that had a spring that was exactly the same specifications as the one from McMaster. And we also ordered one from McMaster. And the two are quite different. The Essentra spring is very stiff and would easily hold 3 gears on it. The McMaster one, it's not at all the same. It's even though it's supposed to be the same specs, it is quite flexible. So that's a very critical thing for the teams to be aware of. We've designed quite a few mechanisms on CAD. They all look pretty good. We're cutting parts. We expect by this weekend to have at least a few of our subsystems in place and ready to start trying on some carpet somewhere.
Very nice, very nice. So Actually, Maurice, if I could delve into just a little bit of detail on your side with the cybercavs, what would you say has been one of the biggest challenges? Because, it sounds like things have been going pretty smoothly, but having done a few builds in my day, nothing ever goes perfectly smoothly. There's usually a few snafus there, but from a mechanical standpoint, have you had any subsystems or mechanisms that, maybe you had to put a little bit of extra thought into or find a unique solution to really try and get that thing going?
I'd have to say the one thing that's been quite challenging for us this year is it's the first time ever we've looked at using a two-speed gearbox. This is a fairly wide open field, and there are going to be times when you want to get from one end to the other fairly quickly. Just getting that two-speed gearbox mounted on our drive base, we had to take the thing apart I don't know how many times. It's on there now, and it looks like it's going to work, but we don't have the air quite hooked up yet to see if we can actually switch gears.
Interesting, which brings me to maybe that's something related because some teams with varying success have chosen to use servos to be able to shift mechanisms like that as opposed to pneumatics. Don't know if I would recommend that in this particular case, but I think your team has been able to leverage the use of servos, a lot more than maybe some other teams. But would you mind sharing some of your experiences, maybe using servos this year, especially since I think the rules have changed regarding servos, which gives teams a lot more options in terms of what they can do with them.
Yeah, if you could pull up that slide that shows the rule statement there. We have used servos in the past quite a bit on our robot. Both years where we had catapult launchers, we used a small servo for triggering the launcher. That was in 2014 and again last year. And that worked quite well, but those small servos had relatively little power, and I couldn't see using them for a whole lot more than just triggering a mechanism. But with this rule change, especially item C of Rule 36, where it says the Rev servo power module may now be used, instead of limiting us to just that 2.2 amps that the RoboReel could supply, we can now have 15 amps per servo power module for driving servos. And Hi-Tech does produce some servos that are pretty good and torquey. If you can go to the next slide, you can see there's a robot arm there. We built one of those 3 years ago. And the main servo down at the bottom is a Hi-Tech 805. And it can produce 24.7 kilograms centimeters of force. That means at 10 centimeters or 4 inches from the center, it'd be able to lift 2.4 kilograms. And that's quite a bit of torque, and it's pretty fast too. They're rated to move 60 degrees in 0.14 seconds, or they could do a full rotation in less than a second. They don't go full rotations. Most servos are limited to 180 degrees. But now that we're looking at being able to use these larger servo motors, there's quite a few interesting things we could do, and we can do it very simply. Even a rookie team should be able to get themselves a servo motor like that, hook it up through the Rev Robotics power module directly to the RoboReel, and you just send it a position command. On our robot, we're thinking there might be a situation where we want to have our hopper side near the top open up so that we could actually dump balls into the low goal. The ideal device for opening up a section of your hopper would be a servo motor like this, especially given how inexpensive it would be compared to using pneumatics or a larger motor controller and encoder and gearbox. That would cost you well into the $300 range. First actually limits us to spending no more than 75 US or about $100 Canadian on each individual servo motor. The ones that Hi-Tech produces, you'd be hard pressed to spend more than $50 a piece on those.
Yeah.
I see servos as being a real potential game changer for sort of that motion that doesn't require quite as much power as a pneumatic cylinder would give you, or the larger motors, but requires more than what those tiny little servos were able to produce.
Yeah, and I think this is timely advice too, because you might be in, that stage of your build season where you just need a little actuator somewhere in your robot to help your gear or your fuel along. And if you've been a team that's been trying to keep pneumatics off your robot this entire time just because of the weight savings and the complexity and things like that, you now have a whole new gamut of servos that you can play around with, which essentially could replace those pneumatics and be a lot simpler, super simple from a programming side. So, Maurice, I'm really glad that you did bring this up, because this is a new thing for this year. There's probably a lot of veteran teams who might have missed this one, who many years ago might have been thinking, oh, I just wish we had access to beefier servos. I could put out more torque, and now we finally have them. And so, coupled with this nice little module where now you're supplying additional power directly from the power distribution panel, you're not limited to the RoboRia anymore. I think this will open up a lot of doors, and what a great tip to share with the teams, especially at around this time, where teams might be looking for a solution, that a quick and dirty servo could just fix it for them. Awesome.
Could I emphasize the real need for that Rev Robotics power module? That's the one that we're talking about. If you go down to the next slide, that robot arm that we built, the picture shown there, that arm is mounted inside that box, and we've built a set of potentiometers in a configuration that mimics the robot arm, so that the challenge is for students or anybody to come along and try and make that arm pick things up inside the box and dump them into a chute that's on the side. We usually put candies in there. The kids love it. One of the challenges we found was when we first turned this thing on, we used a 4 amp 6-volt power supply, which I thought would be just fine and dandy, but it was a switching power supply, and it would overload and then cut back in about 2 or 3 times per second. So this robot arm, we first turned it on, it was just bouncing around. So our robot arm is now called Twitch, quite appropriately. That just emphasizes the need for sufficient power supply for these larger servos. You've got to use one of those Rev power supply modules. And the last time I checked, there were actually a few still available on First Choice by Andy Marks. So any rookie teams or other teams that didn't use all their points, go grab those things. You could use them. They could be very, very handy.
Yeah, and I think that just goes to show there's a lot of teams who missed out on these new servo rules, because I think if a lot of more teams had been paying attention, these guys would have been snapped up pretty quick either way. But really, really great point of information there, Maurice. I'm glad you were able to share that. I did want to delve into a few more questions, though, specifically with your robots. Well, now that you're about 3 weeks in, I'm curious to know, are your robots about as good as you would hope they would be? Because I think every team sits down on the very first day after the game is released, and they plan out their strategy. They have this vision of how the game is going to be played and what your robot needs to do. And so I guess maybe if I was still on 610, I'd say, yeah, we're going to build this robot that's going to score, 5 or 6 gears in a single match and just cycle them back and forth. And this is about the time where you get to, it's a bit of a reality check. You look at your robot and you see, ooh, I don't know, that 5 or 6 goal is looking pretty far away right now. Or maybe you're thinking, you know what, I think we can do that. Or maybe we can do even better than that. But Matt, we'll sing this one back to you. Based on what you've seen so far for your robots, or is it shaping out to be about as good as you'd hoped, or still have some work to do? Like, you optimistic about this one, or where's your mindset at?
Yeah, we're cautiously optimistic. I guess for us, new game every year. We've been around for a few years, but we're not as seasoned as 610 or some of the other teams from Ontario and beyond. And so for us, how good is good is the question. Have we set our sights too low? Are we going to be competitive? Where do we fit in the whole thing if we execute the strategy that we had originally anticipated? And I don't think we're going to know that until we start to see some of the matches being played in week 0 and week 1 and see where people are, and then see as the season progresses our particular situation. We don't play until week 5, I think. So we've got a long time to watch the other teams improve and get better, and so maybe good enough as far as where we thought we should be, might not be good enough by week 5. And so that's, for us, the thing. Did we set ourselves too low of a target? We're kind of doing well in terms of the goals that we set for ourselves. But it was interesting this year because I think I've heard from a lot of teams that this year it seems like you can do everything. And I hearken my team back to what Karthik says about trying not to be good at everything, because typically you can't. And I don't know whether this year is an exception, but for my kids, We emphasize that during off season. We emphasize living within your means and doing what you can with what you have. And one of those things is not trying to bite off more than you can chew. And so this season it was, we kind of drew a triangle. After we had done all our prototyping, we had done our strategic analysis, we had figured out not only where you got the points, but how hard it was. We figured, based on our prototyping, to achieve each one of those things. And we made a triangle, and on each of the corners of the triangle there was fuel, there was gear, and there was climb. And going along with the principle of don't try to do everything, we challenged the kids to pick 2 out of those 3. And despite my best engineering, my efforts to instill engineering practices and highest reward for least risk and so on, the students decided that they would choose maybe the 2 things that I wouldn't have chosen myself, but we're going with that. And so we're concentrating on 2 out of the 3, and we're going to nail those, and if there's time left, then we'll try to get the 3rd one, which I think at the middle to high levels of play you'll have to be able to do all 3 of those things. But this might be, maybe we've got it wrong, or maybe the tasks are harder than they originally look, that doing 2 out of 3 will get you a fair ways, we think, if you do them really well.
All right. And
so
I want to come back to you on that one, Matt, because we may talk a little bit just about what trade-offs you had to make in order, to get those 2 out of the 3. Although I get the sense it might be more like 2.5 out of 3 that you're going to be able to do. But before I do that, I'd like to swing this one over to Maurice. Maurice, how about from your standpoint with the Cyber Cavs? Or is this robot shaping out to be about as good as you'd hoped based on that day 1 strategy discussion? Are you going to be able to hit pretty much most of your strategic objectives, all of your strategic objectives, or even better than them? You've surpassed your goals, or you're still not quite there yet?
Yeah, that question's a little bit premature for us. Like I said, we just got the drive base going. How all of the different subsystems work, they still work perfectly in our minds. What they really do once we get them on the robot, that's going to require us to maybe either tweak the subsystem or go in a different direction. There's not a whole lot we can change now that we've got our robot plan pretty much in place. We know what we're going to use for drive base. We've got a really good general idea of how it's going to be shaped and the size and all that. I think if you were to ask me a week from now, I'd be able to answer that question a lot better than I can right now.
All right, well, I'll ask a little bit about the trade-offs. So I'll swing this one back to Matt, because I think at this stage, yeah, you're right that it's hard to tell how good your mechanisms are going to be, but by this stage, you know which mechanisms are going on your robot. So Matt, please don't hesitate if you aren't willing to answer the question. I'll give you an out. Just say can't really say, but I just want to run through some functionality on your robot. I'm assuming you're going to be able to get gears from the loading slots and score them on the pegs, right?
Yeah, that's the plan.
All right. How about picking up gears off the ground?
So that's an interesting one, because at the start of the season it was one of the tasks that we had identified that robots could do, but we had ranked it relatively low based on what we thought of the game at the time, and difficulty to be able to achieve it and package it within the other things that we wanted to do. But interesting one that you bring up, because I think in the last week or so, given some of the discussion on Delphi and people that you talk to, that the importance of a floor pickup, we might have underestimated that, because the gears, we talked about the spring already, and we talked about lifting, the pilot lifting. There's probably a good chance that there are going to be gears on the field in many places where they're going to get in your way. And maybe in autonomous also, there might be an opportunity to do something clever in autonomous if you had a gear pickup. So I think it's probably a good mechanism for a team that spends the time on it, gets it right, and is able to fit it within the packaging of the robot. But for us, there's no plan right now to try to pick up from the floor.
Well, I'll echo that one, because I've come across a few, higher level teams who have pretty decent resources, and in terms of trade-offs, that's a trade-off that they were quite comfortable making. I don't know if they're going to regret it down the road. Like, I don't even know what to say in terms of that one. It's impossible to predict because, what they're choosing to really excel at, and I guess you would say they've chosen the ability to shoot fuel into the high goal boilers, high efficiency goals. Maybe that ends up being much more important, and if it is a trade-off, it's going to be worthwhile in the end. But a very interesting one just to sort of get into the heads of some of our more successful teams and where they stand on that one. Matt, very quickly, are you guys planning on being able to score fuel into either that high goal or low goal?
We're going to try our best. We think the fuel, from a strategic point of view, we think fuel will increase in importance the further on that you play, and if we're lucky enough to do well enough at a regional to play in the elimination round, and then if we're lucky enough to play at districts championships, then we think as you move along, a team that's going to be standing at the end is a team that is able to effectively do fuels. Now, how effective is for fuels, it's a tough game object. There's no scientific data on how to launch a wiffle ball repeatedly, and so I think the aerodynamics is something that teams are working through. We haven't solved that yet. We've got something that works, but we've got a lot of refinement and dialing in to do to get it where we want it to be.
Okay, and last but not least, you are planning on climbing, I would assume.
So that's the third point of the triangle, and that's where I've been losing a lot of sleep lately, is that, as I said, the students on our team made a choice to prioritize that as a third, and even though it's guaranteed points and there's no defense and it's a significant amount of points, we've decided, rightly or wrongly, to prioritize that as a third priority on our robot. Well, that doesn't mean that we won't do it, but it means that we're going to try to nail the first two and then come back to that one.
But you know what? That is engineering, and engineering is a field of coming up with the best solution with your limited resources, and you have to be realistic about those limited resources. So, I don't know if that's necessarily a more common one, but I can understand, definitely the philosophy and the approach towards it. So kudos to you guys. Maurice, I want to throw that one also to you if you don't mind, but in terms of trade-offs, I guess I'll go through them as well. The more interesting one that Matt addressed would have been the floor pickup for gears. Are you guys planning on being able to pick up gears off the ground?
We decided almost right away that yes, we would be picking up gears off the ground. We've kind of got a philosophy that we like to be the team that does something a little different. Last year with our arm, we were very successful at pulling that off, and we looked at it and we thought, at some point in this game, there's going to be a gear on the floor. We want to be that robot that can pick that thing up. So we've planned rather seriously for that.
Yeah, and as a result of making that decision, though, have there been any notable trade-offs that you had to make in order to take that functionality? Because a ground intake is relatively expensive space-wise and complexity-wise, but are you giving anything up in terms of climbing, shooting in the high goal, or being able to load fuel, or even gears for that matter from the slots, or are you really just trying to pursue everything and everything, anything and everything?
The one thing we would give up is a very reliable slot to drop the gear into. We're going to go with the theory that being able to get that gear off the floor is going to work almost as good as dropping it through a slot. Now that we've got the design all done, if we had to, we could probably add something onto our robot to do that. Now, that being said, in order to be a really effective gear pickup robot, you've got to be able to reach outside of your bumper to do that. And with the kind of defense that's going to be played this year, whatever's hanging over that bumper, it better be built really, really tough. So the whole design of a gear pickup that's outside of your bumper area, that's been a big challenge for us.
Yeah, I can agree that defense is going to be pretty aggressive. Well, I'll move actually a little bit quicker here because I think we actually covered a lot of the predictions about the gameplay and how they might have changed from the beginning versus to midway through build season as a result. But just before we call the official part of the webinar, call it wraps, I'd like to ask you guys about practice. This is one thing that a lot of teams, particularly younger ones, don't do a great job at, and a lot of it's, not intentionally. They just don't leave enough time at the end of the build season to be able to practice with the robots. But even if they do leave a day or two, I think it'd be a good opportunity just to give them a few pointers on how you maximize that time. And so for teams like yours, what do you guys do for practice? If you could give some advice to the younger guys who maybe only have a day or two, what are you going to have them run drills with or do with those practice or with those robots to practice? Matt, you have any thoughts on this one?
Yeah, drive early, even if your robot isn't completely finished. Get your drive base out there, get your drivers driving. We have wood contraptions on our robot right now. It doesn't have to be the final version, but if you can get out, get to a field, get a feel for how long the field is, how many cycles you can do. If you need a realistic practice field, come to Hamilton. We've got a nice setup the teams here are using. When you do your practice matches, do a simulated match, so include your pre-match checklists, how you place the robot on the field, who does what, run the autonomous, and try to make it as realistic for the drive team as you can. And repetition, especially of gear cycles, do it solo, do it with defense, if possible do it with partners, and make sure you explore all the areas of the field from all the different driver stations, so including climbing, because line of sight is a big thing. And again, try to make it as realistic as possible. Set the timer, have somebody keep time, have somebody keep score, and review the matches afterwards, just like you would do at a regional. If you've only got the last couple days of build season to do it, then try to get out there as much as you can. If you don't have a practice robot, then those hours are going to show you things not only about the driver, but about the robot itself, where it's going to break, where the weak points are, and what you need to look for.
That's right. Better to break it week 6 when you still have some time to fix it than to break it at competition. Maurice, any final thoughts on practice? How do the Cybercavs go about their practice routines?
We'll do quite a bit of practicing in whatever room we can get available at the school before bag and tag day. It's a pretty common practice for a lot of the teams to build either a second robot or 1.5 robots and use that holdback allowance so that practice can carry on after bag and tag day. We'll be doing some of that also in cooperation with the other teams in our area. We do plan to have a field of some kind set up during March break where we will actually compete against other robots. That last year was sort of the most valuable thing we did. We also have the good fortune of having later competitions like week 5 and 6. One thing that I think we really need to concentrate on this year is to get our human players up to speed. Those human players up in that tower, they're going to have to be agile and fast, and they can't be klutzes. If they drop that rope, it's going to be tough to do anything in that match. Also, the human players running back and forth in behind the return loading station back to the return bin without stepping into the Alliance station area, that's something that needs to be practiced, and those human players need to know the rules down cold.
Yeah, that's something that's definitely overlooked, your human player aspect of it. There's so many teams which put the human players out in the field for the very first time at competition, and they'll step into the wrong zones in that loading lane for sure and take penalties, and it's the worst way to lose a match. And yeah, that's when your player in the airship, when you're manipulating those lifts, there is a handle attached to a rope, and really you just pull on that handle and the lift rises up. But that handle can actually fall out of the airship and back down onto the field, and it's really not that hard to do. It's sort of, if you pull on the lift, if you pull the handle and the lift is up and you let go, it's hard to describe, but the weight of the lift will come kind of slamming downwards, and it'll kind of launch the handle out onto the field. So you've really got to watch out for that and really make sure your people up there are some of your most responsible, detail-oriented students, because one dropped handle it's probably going to be the match for you, especially if you're in the elims or playing at a high level. Thanks very much, both of you, for sharing your insight. Just before we switch over to the question and answer from the audience, and I'll actually remind the audience members, if you have a question for any one of us, please go ahead and open up the chat section of the webinar interface and start asking your questions, and our moderator, Paul Keenan, will compile them and ask them in a few. But I'm just going to take literally 2 minutes here just to run through the most common question and answer questions and the answers. It's kind of what you need to know about the team updates and the question and answer answers that could potentially affect, you know, your robots and what you're doing on the field. So very quickly, one thing you guys want to note is in the elimination rounds, when you have your alliance, you're going to have an alliance captain, your first pick and your second pick. They've changed the rules up this year where your alliance captain is always going to go in the middle. Well, that's not a change. But your first pick is not going to be in driver station 1 because the field is not symmetric. Driver station 1 on the red alliance and on the blue alliance are actually in different spots. On the red alliance, it's closer to this return loading station. On the blue alliance, it's actually closer to the boiler. So they've changed the rules. They've said your first pick, they got rid of, you know, alliance station 1. They've said that they are in the alliance station closest to the boiler. And so if we look at this diagram, your first pick, boom, is going to be at the bottom of the diagram over here, right beside the boiler. Alliance captain is in the middle, and your second pick is now going to be right by the return loading station, and in our diagram that's up at the top. So that's a pretty major change, just so that you guys are aware of that. Bumpers and robot volume, I think this has been brought up a few times, but there are some rule changes on how big your robot is, and they've given you now 2 options for robot volume, maximum dimensions of your robot, and in the past they did not include your bumpers, but this year your maximum robot volume dimensions do include your bumpers. But your robot volume is not the same as what used to be called a frame perimeter. And so your robot can extend past your frame perimeter over your bumpers, but they can't extend past this new concept called a robot volume. That robot volume is sort of like your absolute maximum dimensions that your robot can extend out to. Ropes, a lot of questions about ropes and Velcro. You've heard us talk about it. Technically speaking, ropes made of Velcro could be constructed a way that appear to be legal. All right, I'm not making a super blanket statement saying that, oh, your Velcro ropes are going to be legal for sure. You still have to read the rules. There's a lot of nuance in there, but you're going to want to pay attention to the question and answer. There's 2 in particular. There's question 6, Q6, where they basically say that a rope made of Velcro is legal, but read it in a little bit more depth. But then there's also question 21, which says that a rope where you've simply attached a piece of Velcro to the end of it, that is not legal. And so you're going to want to, if you're planning on going the Velcro route for your climber, you definitely want to read both question 6 and question 21, and also team update 2, because they go into the rope dimensions and what they can made out of and tying knots in gory detail. A few final ones. There was an error a long time ago in the original drawings and dimensions of the field where the baseline was incorrectly, the distance from the baseline to the wall was incorrectly stated. The proper distance is 7 feet 9 inches, 9 3/4 inches from the wall, which is not that far. So you'll notice that this baseline is used for autonomous mode. So your robot doesn't have to drive quite as far as people thought in order to break the plane of that baseline. Another thing dealing with this baseline and that new dimension, in order to score the points, you just have to cross the base, or not cross it, but break the plane of the baseline. So your robot, some part of it just has to get over it. But you can actually back up. And before the end of autonomous, you don't have to be across the baseline. If you just kind of cross it temporarily, then come back, you will still earn your points for autonomous. So if you have an autonomous that has to do other things where you want to load, you know, back in this area here, but you only want to cross the baseline temporarily at the beginning of autonomous and come back, that's totally okay. They specified some goal capacities for the boiler. That was in a team update. So the low efficiency goal can hold 70 balls. Past that, you run the risk of them spilling out. The high goal, however, has a capacity of 150, so more than twice as much. But if you overfill that, they have a tendency to spill out as well. This was an interesting one where I believe it was I believe it was Maurice who mentioned that with one of the springs on the lift, he was able to put 3 gears on that spring, and the spring was stiff enough that it could carry it. So there's a question that says, are you even allowed to put multiple gears on a lift and lift more than 1 gear at one time on that spring? There are no rules preventing you from doing that, but there might be some laws of physics and springiness that might prevent you from doing that. But that was question 20, was asked in a very clear answer saying that there's no rules against trying to lift multiple gears on that lift. A very interesting question that came up was when your robot is trying to climb, and if you're trying to climb at the center rope right over here, you'll notice that there is a rope station and there's also a lift kind of right in the same spot. There was a question asked that can your airship person pull the lift up so that it is up and out of the way, so that spring is out of the way for a robot to come in and grab that rope. 100% that is totally legal, and in fact for any team that's going to be climbing at that middle station there, I'm going to outright recommend it and that you practice it. Make sure your driver is getting that lift up and out of the way when you're coming into climb so it doesn't interfere. And last but not least, this is the one that I wanted to end with. Question number 54. This one deals with controlling more than 1 gear at one time. So I think pretty much everyone knows that you're only allowed to carry or to possess 1 gear at one time. But what happens if there is a gear on the floor and you have to push it out of the way in order to score? The act of pushing a gear out of the way is considered kind of controlling that gear. And so you're now, if you're holding a gear that you're trying to score, and at the same time, if you're pushing a gear along the ground out of the way, that is considered controlling 2 gears, and you will be called for a penalty on that. So you have to be very, very careful in situations like that. I have a feeling that this might be one of the most common penalties which will be called because, you know, teams are just going to focus on scoring. They'll go and pick up a gear. They'll see there's a gear in their way. They'll just shove it without thinking about it, and that'll incur a penalty. So that's going to be a tricky one. But Paul, I think that pretty much concludes it for our formal part of the Q&A. Actually, before we head into the questions, I just want to go over next week's webinar and remind everyone that next week we won't have any guest panelists. It's going to be more of just a crash course from me on how to program some basic robot functionality in Java. We'll step through it kind of from beginning to end, how to get your motor spinning, a basic robot driving, and maybe some very simple motors and arms, actuators, shooters, just running for you. But Paul, would you mind moderating a few questions for us, seeing we can now take some questions? Paul, I don't think is on with us currently, or he may be muted, so I think I can try and pull these up myself. But I think we have a question here from Alan Toms, and he asks, is a second chassis with no subsystems useful for drive practice? We will most likely not have our competition robot ready for much practice. How much will chassis-only driving practice help? I'd like to fire this off to both of our panelists because I think you'll have pretty strong opinions on this one. But Maurice, in your opinion, even if you just had a basic chassis, how useful is that going to be for practice?
I think what would make it most useful is if it was possible to take one of the subsystems, at least one of the subsystems off of your actual competition robot and mount that on your chassis so that you have at least one system to work with. You've got a 30-pound holdback that you can, as long as what you take off of your flight bot doesn't weigh more than 30 pounds, you'd be able to mount that on your practice bot and just keep on practicing right up until that first week before your district event, in which case you'd have to take your robot out of the bag, your flight bot, and put everything back on it. That would be extremely useful.
Matt, your thoughts on a chassis-only practice robot?
It's much better than nothing, and for your drivers, there's lots that you can do. Try to make it realistic by making up the weight or the size of the missing elements and drive it as much as you can. Drive it and get a feel for, even if it's just a drive base, you can come up with maneuvers as far as defense. So if you're being defended, There's certain moves that your drivers can work on that will help them when the real robot is on the field. If there's ever an opportunity for you to play defense, and this year defense will be a big thing, so even that act of getting that dry base out there and trying to play defense on other robots, definitely it's worthwhile to have a dry base. If you don't have all the systems on it, try to simulate it as much as possible, and get your drivers used to the line of sight and used to the rules about how far they're allowed to migrate out of their alliance station to be able to see the field as best as possible.
Yeah, I mean, I'll share this one because 610 doesn't build full practice robots. We might be lucky to have exactly this, you know, a second chassis with no subsystems. If we're really lucky, we'll take Maurice's advice and we'll pull, you know, maybe our most important subsystem off of our robot, our real competition robot, use it towards our 30-pound withholding allowance, mount it onto the separate chassis. But even without that extra mechanism, we would just drive and we would do very specific drills. And so, for instance, if we were a gear scoring robot, we would start our timer, 2 minutes and however many seconds, you know, start it where we think our robot's going to be at the end of autonomous, and we would literally drive to the retrieval zone, and we would tape off a very tight area that our robot had to hit exactly to be perfectly lined up, theoretically, to receive the gears, and our drivers would have to do it. They would have to hit that exact zone with no margin of error, and if they missed it, we would tell them, you got to back up and drive into it again. And then they would drive, you know, and we might get them to cycle through all 3 lifts and keep driving back and forth and hit all the 3 different lifts. We might tell them to take different routes, either around the front of the airship or around the back of the airship, to simulate there being defense played against us. And, you know, if you're planning on shooting fuel or dumping fuel, you know, we'd also simulate that. But we'd also take the robot out to a practice facility. Now, Team 610 does run an open practice. Matt has also mentioned that out in Hamilton, they have the Robodrome out there, which is available for practice as well. You know, if you only have a practice chassis, I'll emphasize the importance even more of being able to play with and against some other robots, so take advantage of that. And speaking of defense, getting into the more specifics there, you know, one really great way you could affect a match that's really simple to practice with just a chassis is a very simple defensive maneuver, which we talked about a few webinars ago. But let's say, you know, you're on the blue alliance here and you're up against some very strong red robots. One of our guests from a previous webinar said that, hey, you know, a blue robot can basically park themselves along this line on one side of the airship where the launch pad line is, and just kind of drive back and forth here and play a little defensive game of Pong. And if you block that corridor, you're forcing all of your robots to circle the hard way around your airship, the long way around, and to load from the retrieval zone from, you know, not a great angle where their line of sight is probably blocked by the airship. And so blocking teams by having one robot drive back and forth here is super effective and a really simple way to affect the match, even if you only had a drive chassis. I think, Alan, you asked a follow-up question, the 30-pound holdback limit. What is this? I'll see if I can take a crack at answering that, but you are allowed to take 30 pounds of assembled robot mechanisms to your competition, and it doesn't have to be in the bag. And so what this allows you to do is to continue to work on a small part of your robot, 30 pounds being small, in between the time of bag and your competition. And so if you had, say, a gear manipulator, a gear scoring mechanism, and it wasn't quite complete, and if it weighed less than 30 pounds, you can choose to not put that in your bag and to continue to work on it. And when you show up at your competition, you have to declare it to the robot inspectors and the people actually at the door and say, hey, this is my 30 pounds of, it's called a withholding allowance. I think that's what you would search for in the rules. But that's basically 30 pounds of assembled mechanisms that you can bring in, which is sort of not subjected to the stop, build, date, and bag and tag rules. So hopefully that gives you a bit of an explanation on that. We'll go to Andrew Champ, who asks, what mistake do you believe will happen the most in matches? I think that's a really great question. Maurice, can I fire that one off to you? Do you have a prediction on what mistake you think will be the most common one in these matches?
Oh, that's tough to come up with in a matter of a couple of seconds, but I'm going to say there's going to be more gears dropping on the floor than we expect.
Yeah. And I'm going to follow up on that one. Not only will they be dropped when robots are trying to score them, so this is like missing the spring or putting them onto the spring and then having them slide off the spring, but I also think teams which are just going to load gears in the retrieval zone, for teams there who are, just trying to load, I think they won't align themselves right up against that back wall and line themselves with the slot, and the gears will spill out and hit the ground, and that's where it's going to be particularly disruptive. If you're trying to load gears and you've got to deal with a whole mess of them on the floor here, it takes a lot of time, and we saw that happen in 2013. So if you want a good game to use as a reference, if you pull up some archive video from the 2013 game, they had a loading zone just like this, and you'll see they were sliding frisbees down these slots. They wouldn't sit and hit the robot properly and get loaded, and they would just end up in a big mess around here, and you would essentially tank your own alliance because you'd misfeed so many of them. Robots literally could not get into that retrieval zone anymore, and you were stuck just not being able to score because you couldn't get any of your frisbees. So that's definitely going to be a very common mistake. Matt, any thoughts on that one? Agree, disagree, something different, more of the same?
Yeah, I think that's definitely one. Another one that I'm thinking of in terms of mistakes is too much time in the key, and along with that pinning. So the G11 rule, I think it's going to be really interesting for the referees, because down in the key area they've got the 5 seconds in the key that they're going to hopefully give hand signals like they have done in previous years. But at the same time they've got to keep count not only of the time that's in the key but the time of pinning. So I don't know how you do that with two sets of timers going off at the same time.
Yeah, and this is going to be pretty critical because there's going to be a few teams, a good number of teams, who are going to be shooting into the high efficiency goal in the boiler. And when you see that happen, this blue robot should be coming over and playing defense on them, not allowing a free shot. But for the teams that aren't super familiar with the rules, you're only allowed to be in there for 5 seconds, which technically is plenty of time to stop a robot from shooting, because you can always just back out and then come right back in again and bother them for another 5 seconds. But that's definitely going to be a little bit of an issue there, and even for the refs to keep track of that. You're right. I think a big mistake, I mentioned it before, if you're carrying a gear and then you need to just push another gear out of the way because it's in the way of your lift or it's in the way of something, that's going to incur a penalty. So I think that's going to happen quite a bit. I think there are going to be some pilots who are going to drop the handles for those lifts so that they basically fall out of the airship, and that lift is basically out of use. Those are probably going to be the most common ones. I hope this doesn't happen, but I know I joked around with some other mentors that there might even be some cases where, if a team isn't paying attention to these return bins here, that if someone's scoring a whole lot and you're not putting them back into the return loading station, you could get some of these fuel balls stolen from you. But beyond that, those are probably the ones that I think are going to be the biggest mistakes.
Can I add one more, Sean?
Yeah, absolutely.
And it's not so much a mistake as it is trying to keep track. There's a lot of things going on the field at once, and for a drive coach to pay attention not only to their own team but to the other teams, there will be teams that are cycling gears near the end of the match for no good reason. After they've achieved the previous rotor, they're going to have to keep track of that and understand when it's time to stop, because they don't have a good chance at the next rotor, when it's time to stop going for the gears and when it's time to concentrate either on defense or on fuel, because those gears that are scored near the end that don't get you to the next threshold, it's really wasted time.
You're better off scoring fuel at that point, because if you have no chance of making them, you're right. It's not worth it. So strategically, that's going to be a huge mistake, scoring gears when really you should have been doing something else. If you had the ability to score fuel, for instance, maybe you should have been doing that, or even playing defense at that point. So strategically, yeah, I think that's going to be a huge one. Well, I think that's kind of all we've got for our questions this evening, which allows us to end, just a few minutes earlier than usual, which is actually great because time to be with the family on these busy build nights. Any few precious minutes we can get are certainly appreciated. But I wanted to take a moment to thank both of our panelists, Matt and Maurice. Matt from 4039 Makeshift and Maurice from 4678 Cyber Cavs. We really appreciate both your time and your expertise, and I think we were able to get, again, some really great information out to the FRC community. And thanks, everyone, and have yourselves a great evening. Take care.